Another really basic construct in programming languages is looping or iterations. And just like it sounds, looping allows you to create code that will get executed over and over and over, multiple times in succession. In practice, a loop might look something like this. Here I've indicated that, while the player health score is greater than 0, it's going to take an action input and then it's going to go through a series of actions depending on what the user inputs, and it will do this over and over and over, right? When it gets to the end of this code right down here, it's going to go back to the beginning and start all over again. It's going to check the player's health and then allow them to input an action. Of course, once the player's health reaches 0, it will kick them out of the software. So looping is all about creating a portion of code that gets executed multiple times. And oftentimes you'll find loops used for user interaction portions of an application, like I've just said here. The program will loop over and over and continue to accept input from the user or continue to wait for input from the user until it's time to continue. And this is allowed to have nested ifs or conditionals like you see here. You can loop or nest loops within loops if you would like. You can mix and match conditionals and loops all you want. These two constructs, conditionals and loops, work together to really allow you to create basic, simple code that can be executed when it needs to be executed as many times as it needs to be executed. I think loops are the first way that we really implement the guideline of DRY, don't repeat yourself. And the whole idea with DRY is that code is likely to have bugs. If you write some code, well, there's a good chance it'll have a bug. If you write the same code twice, there's a good chance it'll have 2 different bugs. And if you need to fix some code, you only ever want to fix it in one place. So what you ought to do is, whenever possible, don't repeat yourself. Create code once, write code once, and have your program reference that single instance of that code and execute it whenever needed. Looping allows you to do that, exactly that. And what's cool about looping too is that, of course, this all happens in runtime, just like the conditional. You can identify, pre-program ahead of time, how many times your loop is going to execute with a for loop, for instance, or you can wait until runtime and you can let the program decide at runtime how many times the loop is going to loop, how many times it will execute, how many times that code will get run. It might get run 0 times, it might get run 1 time, it might get run a whole bunch of times. Now, there is, of course, some danger with loops, just like any programming construct. We give you the tools. You can shoot yourself in the foot with these tools. And in the case of loops, what you got to watch out for is the dreaded infinite loop. Infinite loops are exactly what they sound like. They are when you create a loop that never has a break. It never has a point where it will stop executing. Look at this little example on screen here. I've said while true equals true. Well, true is always going to equal true. This loop will continue ad infinitum, over and over and over, running and running and running, and this program will never end. It will never stop. This is a serious problem. You've likely heard about infinite loops before in programming. If you are a novice programmer, if you're new to programming, it's an easy pitfall to fall into. How do you avoid it? Practice responsible looping. What does that mean? Well, in practice, it can mean a lot of different things, but at very least, don't do this. Don't ever have a condition for your loop that is by default infinite. I've, believe it or not, seen this used in real time in production, and I've heard developers justify its use. I don't like absolutes, but I think this is probably absolutely never a good idea to do. Do not have a looping condition that by default is going to be infinite. You should always have a break condition right inside of your loop definition. On top of that, you want to be careful about modifying the terms of your loop inside of your loop as well. So if you have a for loop that is going to execute a certain number of times, or is going to execute until it reaches the value of a variable, try not to adjust that variable inside of the loop. Always define your break terms. Always understand with every loop what your breakout terms are going to be, what would cause you to break out of a loop, and write tests. Ensure that you write tests that try to cause an infinite loop. Look at your loop and say what might cause an infinite loop, and write your tests, your unit tests against that code so that you know your loop will not get stuck in an infinite loop anyways. So that covers looping and iterations, which are basically the same thing inside of programming. Another construct for organizing your code, and in this case, one that's going to help you to don't repeat yourself. I hope this has been informative for you. I'd like to thank you for viewing.